The remainder theorem is very useful for evaluating polynomials at a given value of x. In the remainder theorem, for any polynomial p of x, if we divide that polynomial by another polynomial of the form x minus b, then the remainder of this long division exercise will always be p of b. And when we divide a polynomial by another polynomial, we have the following components. We call p of x is the dividend, x minus b is our divisor, q of x is our quotient, and r is our remainder. And you can ask me, why is it p of b? If you remember from yesterday, we said that any polynomial p of x divided by x minus b can be written in the form p of x equals x minus b times q of x plus r. Well, what does it mean to have p of b? Well, it means that instead of x, we substitute the value b at x. So p of b equals b minus b times q of x plus r. Well, what do you notice here? B minus b will equal 0, which means the entire term x minus b times q of x will be eliminated. Therefore, we can say that p of b equals r, or the remainder. As a concrete example of p, b, q, and r, let's look at the polynomial p of x equals x cubed minus 7x minus 6, and let's divide it by the linear binomial or the linear factor x minus 4. So what does b stand for? Well, b is that value inside of the bracket of x minus b or x minus 4, so b equals 4. Well, first let's see, what does p of b equal? Well, p of b, or p of 4, means I'm going to substitute that value 4 inside of my polynomial p of x. So we have 4 cubed minus 7 times 4 minus 6, which will actually equal 30. Well, can we verify if this remainder, which means that the remainder will be 30 if I divide p of x by x minus 4. Let's verify that by doing a long division step. Right, so we have x minus 4 as the divisor and x cubed minus 7x minus 6 as the dividend. However, we said that when we are missing a term of consecutive degree, we have to put in that term even if it has a coefficient of 0. So we have x cubed plus 0x squared minus 7x minus 6. So we just verified that if we divide our polynomial p of x by the binomial x minus 4, it is true that the value of the polynomial at 4 equals the remainder of that division, which is 30. Which is very powerful information and useful for us to find missing pieces of polynomial functions at some point in time. Let's remember those key concepts again. So the result of the division of a polynomial p of x by a binomial of the form x minus b can be written as p of x equals x minus b times q of x plus r, or p of x divided by x minus b equals the quotient plus the remainder divided by x minus b. To check the result of a division, please use that the polynomial function at the value of b will equal the remainder. Now you may say, well, this is no new stuff. I know how to divide. I get it now. I can substitute p of b and find the remainder without going through the long division steps. But how can I use this in a useful way if I don't know certain things about polynomial functions? P of x divided by x plus 2 determine the remainder. So how do we determine the remainder? Well, you're going to say that the polynomial value at -2, which is the b value, will equal the remainder, and I'm going to let you find it. For the second one, we have a polynomial p of x. We have our divisor 2x plus 5, so we know it's of the form ax plus b. So in this case, what is that b value? Because it's not just b. Well, it is the polynomial at negative b over a. In our case, is the polynomial at negative 5 over 2 will equal the remainder. I'm not asking you to factor, I'm not asking you to find the quotient, I'm just asking you to find the remainder. However, let's take a close look at example 3, which is a bit more interesting. When the polynomial p of x, which equals x cubed minus kx squared plus 17x plus 6, is divided by x minus 3, the remainder is 12. Find the value of k. In this case, we are given a polynomial p of x, but incomplete information about that polynomial. However, we are given other information. We know that when p of x is divided by x minus 3, the remainder is 12. Whenever you have a similar type of problem, right away I want you to think of the remainder theorem. Well, we know that when we divide two polynomials, p of b equals the remainder. In our case, that b value is 3. So I can say that the polynomial at 3 equals 12. Well, why is this information useful? Well, if I substitute 3 in my original polynomial, I notice that I'm actually going to be left with one unknown, which is k, and a linear equation that I can solve for k. So let's see what that looks like. Let's substitute 3 in the original p of x. So we have 3 cubed minus k times 3 squared plus 17 times 3 plus 6 equals 12. So what does that mean? Well, if we isolate the k term and we leave it on the left side, it's negative 9k equals, well, we have 27 plus 51 plus 6, so 12 minus 84 on the right side. Negative 9k equals negative 72. Opposite operation means we have to divide both sides by negative 9, which means that k equals 8. And now we can say that the polynomial that was given to us in the original form, p of x, is actually x cubed minus 8x squared plus 17x plus 6. That's the original polynomial. Example 4 is not much different than example 3. However, what do you notice? We are missing two critical coefficients in this polynomial, the coefficient of the x squared term and the coefficient of the x term. So we have two unknowns, c and d. First, we know that when it's divided by x minus 2, the remainder is negative 3. What does that mean? That the polynomial at 2 will equal the remainder, which is negative 3. The second piece of information is that when p of x is divided by x plus 1, the remainder is negative 18. So the polynomial at negative 1 will equal negative 18. What I want you to do is to substitute 2 inside the polynomial and set up an equation, even if you have two variables, c and d, and then substitute negative 1 in the polynomial, and again you're going to have an equation with two unknowns. However, what we're left with is a system of equations with two unknowns, and we learned to solve these ones in grade 10 in linear systems by using either substitution or elimination. For verification purposes, I'm going to provide you with the proper equations in simplified form. One equation will be 4c plus 2d equals negative 20. Sorry about that. And the next equation will be c minus d equals negative 8. The proper values for c and d should be c equals negative 6 and d equals 2. And happy solving. And that's it for today.